Your checkpoints are killing performance. Here is what happened. Default PostgreSQL, max_wall_size equals 1 GB. Nobody changed it. A batch job runs overnight. 2 GB of WAL generated. Max_wall_size exceeded. Forced checkpoint. All dirty pages flushed to disk at once. I/O stall. Queries spiked to 10 times normal latency. Users see timeouts. 1 GB is the default. Production needs 4 to 16 GB. And checkpoint_completion_target at 0.9 spreads the writes over 90% of the interval. Every insert and update goes to WAL first, data files second. Misconfigure checkpoints and your database freezes under load. Stay to the end, I show you exactly how to diagnose and fix this. Every change hits WAL before it touches data files. That is the durability guarantee. The right path, your transaction writes to shared_buffers, dirty pages in memory. At the same time, the change goes to wall_buffers. On commit, PostgreSQL calls fsinc to flush wall_buffers to pg_wall on disk. That is the moment the transaction is durable. Later, a checkpoint flushes dirty pages from shared_buffers to the actual data files. If the server crashes, PostgreSQL replays WAL from the last checkpoint to bring data files up to date. Key concepts. LSN, log sequence number. A byte offset into WAL, always increasing. Full_page_writes, after each checkpoint, the first change to a page writes the full 8 KB page to WAL. Torn page safety. More checkpoints means more full page images means more WAL. Wall_level, minimal, replica, or logical. More detail means more WAL volume. And fsinc, never disable it. The performance gain is not worth silent data corruption. 2 types of checkpoints. Timed, fires every checkpoint_timeout. Default 5 minutes. Writes are spread over 90% of the interval thanks to completion_target. Smooth, predictable I/O. Forced, max_wall_size exceeded. PostgreSQL urgently flushes all dirty pages. I/O storm. This is what causes the performance problems. The configuration. Checkpoint_timeout, set to 15 minutes for production. Max_wall_size, 4 GB minimum. 16 for write heavy. Min_wall_size, 1 GB so WAL files are recycled, not removed. Checkpoint_completion_target, 0.9. Spread writes over 90% of the interval. Log_checkpoints, on. Always. See write time, sync time, distance, and whether it was timed or forced. Wall_compression, ZSTD on PG15+. Compresses full page images. Reduces WAL volume 40 to 60%. Rule of thumb, if you see checkpoints are occurring too frequently in the logs, increase max_wall_size. WAL configuration. Every parameter explained. Wall_level. Minimal, crash recovery only. Replica, adds streaming replication and PITR. Logical, adds logical decoding. Default is replica. Never set minimal in production, you lose replication and point-in-time recovery. Wall_buffers. Default autotunes to 1/32 of shared_buffers. Usually fine. Increase to 64 MB for write-heavy workloads. Synchronous_commit. 5 levels. Off, do not wait for WAL fsinc. About 600 milliseconds of data loss risk on crash. Local, wait for local WAL only. Remote_write, standby received but not synced. On, standby WAL disk. Remote underscore apply, standby applied. The strictest. You can set synchronous underscore commit per transaction. Set local synchronous underscore commit equals off. Perfect for analytics tables where you accept the small data loss window. Archive settings. Archive underscore mode on. Archive underscore command copies completed WAL segments. Archive underscore timeout forces archival if a segment is not full. PG15 adds archive underscore library for built-in archiving. Your monitoring dashboard. 3 views. PG underscore stat underscore wall underscore records, wall underscore bytes, wall underscore buffers underscore full, wall underscore write, wall underscore sync. This tells you how much WAL your workload generates. PG underscore stat underscore checkpointer. PG 17 plus. Number underscore timed, scheduled checkpoints. Number underscore requested, forced. Number underscore done in PG 18, completed. Write underscore time and sync underscore time in milliseconds. Buffers underscore written. The goal, number underscore requested equals 0. All checkpoints should be timed. If the ratio of requested to total is above 10%, your max underscore wall underscore size is too small. PG underscore stat underscore writer. Buffers underscore clean. How many the background writer handled. Max written underscore clean, how often it hit its limit and stopped. If max written underscore clean is greater than 0, increase writer underscore row underscore max pages. Quick health check, select number underscore requested, number underscore timed from PG underscore stat underscore checkpointer. Calculate the forced percentage. If it is above 10%, increase max underscore wall underscore size. WAL archiving. The safety net. Enable archive underscore mode, set archive underscore command to copy segments to your archive directory. Set archive underscore timeout to 5 minutes so partially filled segments get archived too. PG15 adds archive underscore library for built-in archiving, no shell command needed. Point-in-time recovery. Stop the server. Restore the base backup. Set restore underscore command to copy from your archive. Set recovery underscore target underscore time to 1 second before the disaster. Set recovery underscore target underscore action to promote. Create recovery.signal. Start the server. PostgresQL replays WAL from the base backup through every archived segment up to your target time. The PIDR timeline SVG, base backup on Monday, WAL segments accumulating, drop table happens Thursday 3 p.m., you restore to 14:59:59. Table recovered. Critical warning, WAL archiving must be enabled before the disaster. You cannot retroactively archive WAL that was never saved. Live demo part 1. Diagnose and tune checkpoints. Left terminal, diagnose. Query PG underscore settings for all WAL and checkpoint parameters. Then the key query, PG underscore stat underscore checkpointer. Number underscore timed 847. Number underscore requested 312. Calculate the forced percentage, 26.9%. Over a quarter of your checkpoints are forced. That is your I/O problem. Check WAL generation, 42 GB since last reset. Write terminal, fix. Alter system set max underscore wall underscore size 8 GB. Checkpoint underscore timeout 15 minutes. Wall underscore compression ZSTD. Log underscore checkpoints on. PG underscore reload underscore CONF, no restart needed for these. Reset stats with PG underscore stat underscore reset underscore shared checkpointer. Wait for some traffic, then check again. Number underscore timed 47, number underscore requested 0. 0% forced. Problem solved. Demo part 2. Measuring WAL and reading logs. Left terminal, WAL on disk. do -shpg_wall. 2.4 gigabytes. Count segments, 156 files at 16 megabytes each. pg_current_wall_lsn shows your current position. pg_stat_wall gives you total WAL generated, record count, and full page image count. Right terminal, checkpoint logs. With log_checkpoints on, you see exactly what happened. Wrote 12,847 buffers. Write time 12 seconds, sync time 93 milliseconds. Distance 1.8 gigabytes. This is how you validate your tuning. Then pg_wall dump with --stats. Breaks down WAL by record type, heap 61%, tree 24%, XACT 10%, standby 4%. This tells you where your WAL comes from. 5 mistakes that tank performance. 1. Leaving max_wall_size at 1 gigabyte. The default is too small for any production workload. Forced checkpoints cause I/O spikes. Set 4 to 16 gigabytes. 2. Not enabling log_checkpoints. Without it you are blind to checkpoint timing, write and sync duration, and WAL distance. Enable it. Always. It costs nothing. 3. Disabling FSINC for performance. FSINC equals off means WAL is not durable. A crash can silently corrupt your entire database. Never disable in production. Tune synchronous_commit instead. For pg_wall on the same disk as data. WAL writes are sequential. Data writes are random. Mixing them causes I/O contention. Symlink pg_wall to a dedicated fast disk or NVMe. 5. Not enabling wall_compression. Full page images after checkpoints generate massive WAL. Wall_compression equals ZSTD on PG15 plus reduces WAL volume 40 to 60% with minimal CPU overhead. 5 topics covered. WAL, the write-ahead log. Checkpoints, flushing dirty pages. pg_stat_wall, monitoring generation. Archiving, point-in-time recovery. Tuning, no more I/O storms. Configuration cheat sheet, wall_level replica, max_wall_size 4 to 16 gigabytes, min_wall_size 1 gigabyte, checkpoint_timeout 15 minutes, completion_target 0.9, wall_compression ZSTD, log_checkpoints on, archive_mode on. Monitoring queries, pg_stat_checkpointer for forced ratio, pg_stat_wall for generation, pg_current_wall_lsn for position, do -shpg_wall for disk usage. From I/O storms and forced checkpoints to smooth-timed, compressed WAL. If you manage PostgresQL in production, subscribe and press the bell icon. Like if this helped. Save for reference. Next up, cheat sheet number 4, PostgreSQL index tuning. vtree, GIN, gist, brin, partial indexes, and explain plus index selection. Dr. Ibrar Ahmed. PostgreSQL deep dives. See you in the next one.